Good morning and good evening. Welcome to ZigmaData, a revolutionary new data architecture platform par excellence. At high level, we have got four components: connect, which is allowing the connectivity to structured data, unstructured data, NoSQL databases, semi structured data, any kind of cloud, APIs, or real time. The compose layer allows in-memory massively parallel processing layer which connects to these data sources, does push down predicate, brings the relevant data, joins, and the resulting data is contained in the contained layer using arrow format, and we use an object storage which is supporting the S3 protocol which contains the resulting data, and finally the consume layer, which is allowing you to access that particular data in different forms for different uses. The heart of this architecture is powered by Apache Arrow, a new data format, in fact, zero copy data format. If you look at left hand side, whenever you are transferring the data from one system to another system, the data has to travel through the network, plus there is an expensive operation called serialization, as well as the opposite of deserialization happens at every layer. But on the right hand side, if we are converting it into arrow format, the serialization and deserialization are completely avoided. Pure bytes are getting transferred from system to system by making the access and applications run much faster, also consuming less CPU. To go to some use cases, this is one private sector bank, and the requirement was to improve the reporting capability, which was taking lots and lots of time, hours, and they wanted a system where multiple data sources can be combined. Not only combined, but avoiding the duplicate copies and then increase the processing time, which we have successfully delivered. The second is for a transportation company where they wanted a cloud-based platform for integrating all their individual data sources with various formats with different velocity and then combine everything into one data lake, which we could accomplish with ZigmaData. Third, a healthcare insurance provider, they wanted to combine the data from multiple data sources which are in fact not talking each other, and then create a CSV format for an external machine learning application vendor and to be daily given in order to predict whether the claim has to be rejected or accepted. So, if ZigmaData was not available, they could have used an expensive ETL tool with lots of resources and done time consuming operations with multiple failure points to generate this CSV file, which currently is able to derive in less than 30 seconds. And finally, that data is loaded into SFTP from where the vendor picks up and then applies the machine learning, returns the data back. Finally, a public sector bank, they wanted to combine their retail, merchant, and corporate data warehouses and then generate the credit approval process to large number of records, which was taking about 8 hours, and we could reduce to less than 4 minutes because of the fast retrieval of the data, and we were able to generate a text file in about 10 seconds. Without much ado, now let's dig into what can we do, and let me illustrate. So, assume that we have got a particular client who wants to send some data, and this is the demilitarized zone at the client's premises, and within the DMZ, the client's databases, everything is existing here where we are representing it as D1. So normally, the client will be writing a very complex ETL process, export the data from the internal databases, and then put it into SFTP server kept at the DMZ zone. The external vendors who want to access this particular data connects to this SFTP server, gets the data, and applies the machine learning on that particular data, returns back the result. And for this particular external vendor, they might be getting the data like this from multiple clients. So this is client 2, this is client 3, all of whom are following the same architecture, and this client or this external vendor is getting the data from all these particular clients. What we can do is that we can get all this data from all these clients using the arrow format, and then in ZigmaData, we have got an arrow connector which allows the data processing to about 40% efficient, allows you to combine the data, apply your machine learning, because once it is an arrow format, they don't have to go through serialization and deserialization, and then send back the result much faster. So this is an architecture for the existing clients who already has this SFTP setup, and we want to pull the data. We will enable Arrow and then pull the data through ZigmaData. Now, let's look at another set of clients. For example, these clients are, let's say, the clients who are going to be new, for example. We can provide a ZigmaData agent, for example, right? So I'm going to call it as Sigma agent, which will be deployed into the client's premises, whose responsibility will be to connect to the individual databases, create the required format for the external vendor the way that external vendor requires it, and sends that data in Arrow, so that you are avoiding ETL, resources, or a couple of project people and hardware resources, etc., completely, and using the Sigma agent, you are going to generate this particular data. This can be replicated for any number of clients, and since we are using Arrow format for all the data transfers, this external vendor is going to get the data much faster. And because it is zero copy, once the data is received at the vendor's place, they can load it seamlessly into R or Python platforms, apply the machine learning, and then return back the result. So a completely automated data in transit through Arrow, allowing seamless connectivity to multiple data sources at client's premises, and finally deliver much value faster, enabling a win-win situation for clients as well as the vendor. Please ask us for a demo. Thank you very much.